Okay, now we're going to look at a different kind of electrophoresis. We're using 3 samples, and this is called a restriction digest of the samples. We're using 3 samples. We're using 2 different restriction enzymes or endonucleases. Spelled nuclease wrong, I'm sorry. After the L there's an E, but that's okay because mistakes happen. And what you're going to see in a moment is even a mistake happened with this particular electrophoretic run. Now, step 1. We talked about this, but you may not be familiar with the concept. We said that if you do more lanes with more restriction enzymes, you can create a clearer picture of whether or not samples are the same or different. Now what I've done is I've drawn this out for you to begin with. And what you'll see here is I've written out our first sample A is in lane number 1 and lane number 2. We're using restriction endonuclease number 1 and restriction enzyme number 2. Those are both on sample A. We'll treat sample B the same way. Again, our variable is the sample. Everything else gets treated the same way. So the lane here, lane number 3, restriction endonuclease number 1, just like we did above. Lane number 4, restriction enzyme number 2, just like we did above, because again, our variable in this case is going to be our samples. Sample number C, letter C, lane number 5 utilizes restriction enzyme number 1. Lane 6, restriction enzyme number 2. So we're utilizing 2 different restriction enzymes, and we're comparing those between the 3 samples, our samples being the variable. Now let's look and see how this turned out. I loaded the gel, I ran the gel, and the results look like this. I have lane 1 cut with restriction enzyme, lane 1, sample A, cut with restriction enzyme number 1. I have lane 2, sample A, cut with restrictions enzyme number 2. I have lane 3, this is sample B, cut with restriction enzyme number 1. I have lane 4. This is still sample B, cut with restriction enzyme number 2. Then I have sample C, lane 5, restriction enzyme number 1. Lane 6, sample C again with restriction enzyme number 2. Now, this lane right here, this second lane, the reason it is so faint, there's a little blue right there, and then there's a little bit of pink right there. The reason this is so faint is when I set up this gel, it had already been used, and there was a hole poked through the well, so the specimen actually leaked out. So what we see is a very faint band, and that's science. What happens, happens. I was able to recognize why. The other possibility for why the band there is faint for lane number 2, you're going to maybe tell me about when you do your conclusions. But if you're wondering how come lane number 2 is so faint when it comes to the dark blue and the pink, in this case, I recognized as soon as I loaded the well that the specimen was leaking through the bottom because somebody had poked a hole in the well with a pipette, the tip of the pipette. But there's another option for why it looks lighter than the others, and maybe you can tell me that in your conclusions. So this is an example again of electrophoresis, but in this case electrophoresis of 3 samples using 2 different endonucleases to create some resolution of the 3 samples. Our samples again were cut lanes 1, 3, and 5 with restriction enzyme 1. Those were sample A, B, and C. Sample A was in lane 1 and 2. Sample B was in lane 3 and 4. And sample C was in lane 5 and 6. And again, remember lane 1, 3, 5, restriction enzyme number 1. Lanes 2, 4, 6, restriction enzyme number 2. These are your results. And now we have to analyze those 3 samples to decide what this tells us. Again, that's part of the process, is to reach some conclusions on the power of restriction analysis and reach some conclusions on these 3 samples that are presented to you.